All right, we're going to look at Chapter 4, Section 3, which is polynomial division. So we're going to look at the remainder theorem, and factor theorem. Now, why is division so important when it comes to with polynomials? Function looks like this. That's a polynomial. The term with the largest, what's called the degree, the largest exponent, that's called the degree, that is called term. The leading term is made up of coefficient and degree. And the last term, the constant term, all it tells us is our y-intercept. What does the leading term? What good is knowing a is the leading coefficient, the number in front of x? What does that tell us? What good is that? What is it? Why is it important to know the degree of a polynomial?
It tells us, what sort of graph,
Yeah.
what sort of equation it is, i.e., like, let's say
It's true, right?
right, and then the slope.
No, it doesn't give a slope. Because with any polynomials, the slope changes everywhere. For example, even with the parabola, the slope here is negative, the slope here is negative, the slope here is 0, positive, positive. And it changes at every point, the slope changes. So it doesn't tell us anything about slope. But what it does tell us, the end, the degree, tells us the shape of the graph. It tells us maximum of solutions. The leading coefficient tells us the size of the graph. If this was our x squared, this would be something like 10x squared. This would be 1x squared. So the leading coefficient tells us whether the graph's going to be narrow or wide. Sitting over there, it's going to be difficult because the screen's always going to be there. So it tells us the direction. A sub n is positive. It's an increasing function. If a sub n is negative, it's a decreasing function. Now we have to remember what increasing and decreasing means. We do that by discussing something called the end behavior. Because every graph has two ends. Has the side where it goes towards negative infinity, x goes to positive infinity. Both ends have a specific direction it has to follow, depending on the degree and depending on the leading coefficient. First column will be the leading coefficient. So if the leading coefficient is positive or if it's negative. If the degree is odd or if it is even. So if the leading coefficient is positive, only thing we know is from the last 2 points of our directions is that it goes up on the right-hand side. Since n is odd, the degree is odd, they have to go different directions. And the reason this is an increasing function, because as x goes to infinity, it keeps on going up higher, higher, and higher. We don't know what happens in the middle yet. If the leading coefficient is negative and n is odd, that means from the endpoints down to the right and up to the left. So if the degree is odd, directions are opposite. If your degree is odd, then we know that both ends have to point different directions. If they're even, they point in the same direction. If A is positive, they both go up. If A is negative, they both go down. We don't know what happens in the middle. So far, so good? Any questions about that? There should be. There should be one distinct question you should be able to ask. What are these points? This point and that point. This point and that point. What are these points? The end behavior. What points are those? These points are the x-intercepts. All of these points that we're talking about are the x-intercepts. So if I had this, I have 1, 2, 3, 4, 5 x-intercepts. A is 2, which is positive, and n equals 5, because there are 5 intercepts. The degree tells us the maximum number of intercepts we can have. So what do we know about the graph of this one going to look like? The end behavior of the graph.
One is going to go up and
Why?
because the n
Is odd. So they either goes up. So is it going to go up on the right or down on the right?
up on the right.
Because 2 is greater than 0. The a sub n is positive. So we know it's going to look like this. So from the last point, it's going to go down. From the last point here, it's going to go up. And what we have to do is figure out what happens in between the rest of those. Let's see. From 4.2, let's refresh our brains a little bit. Example 3. Polynomial is x to the fourth minus 7x cubed 12x squared plus 4x minus 16. Graph that. Catch this one, in other words. So looking at this equation, what can you tell me about the graph?
Well, 4 x-intercepts?
Nope. The word in there you're not supposed to use. You said there are about 4 x-intercepts. Is it 4 intercepts or is it not 4 intercepts? You can't say about 4 intercepts. The only thing you should look at, first off, make sure it's in decreasing order. The first and the last terms are the only ones you should look at. We know this tells us the y-intercept. Wow, this thing always get out of focus? This tells us the shape and the direction of the curve, the leading term. So what is a sub n and what is n? A of n is 1. It's the number in front of the x.
And it's 4.
N is 4. So with our table, n is even, and A is positive. So what does that tell us? Tells us what? What else does it tell us? Which direction? You're telling me. It's up because A is positive, right? So we know from the endpoints it's going to look like this. And the y-intercept is going to be negative 16. What happens between there, we don't know yet. Actually, to be honest with you, we don't even know if there are 4 intercepts. Because the first thing we have to do with our equation is we have to factor it out. That's what we have to do first. But this taking a polynomial and finding the factors, that's the next section. That's what we're getting to in the next 2 sections. So I'd give you this, and up until now you wouldn't be, but I would give you this. Looking at this, see that there's 2 of those. So once you factor polynomial, you have the x-intercepts. So what are my x-intercepts?
X-intercepts are 1 and 0 for the first x-intercept. The next 2 will be negative 2.
No. Once you factor these things, set them equal to 0. These are the x-intercepts. These are solutions. Remember, solutions are your x-intercepts. Because when you factor these things, you set the equation equal to 0, and that's what we do now. And it's also always going to be the opposite of what's inside the parentheses. So my x-intercepts are at negative 1, positive 2, and positive 4. But there's only 3 of them, and we have a degree 4. So we found our x-intercepts. We know that A is 1, and the degree is 4. So from the endpoints, the last points in my graph, we know it has to go up. We also know our y-intercept. So sketching this graph, if we're going in from negative infinity, we're going down here, so it's got to cross here, cross that point, go back up, Now the question is, what happens in the next point? What happen here is it's going to bounce. It's going to look like this. What's the degree of our equation? 4, yeah. This is also the degree. But if I gave it to you in the factored form, do we still have degree 4? Degree tells you how many solutions. We have 1, 2, 3, 4. So if you look at these exponents, each of these have an exponent of 1. If I add those exponents, I get the degree 4. So in the final factored form, this one has an exponent of 1, this one has an exponent of 2, but if I add those together, I still get 4. Add these exponents on the parentheses. These exponents here, those are called multiplicities. Those are called multiplicities. How many times the solution is repeated? Let me show you this one. Okay, let's look at this example. F of x is equal to 2x cubed, x squared, 8x minus 4. We did discuss while I was gone, and we did discuss we can factor something like this. How? First thing, since it only has 4 terms, method called grouping first to see if it works. Put a parenthesis around the first 2 terms, and I put a parenthesis around the second 2 terms. It's called grouping. Grouping only works is if we get the same factors. Now, in each of these parentheses, factor out what they have in common. What does the first one have in common?
First one they have in common is x.
Two x's. They have x squared in common. This one has 3 x's, this one has 2 x's, so they both have to have at least 2. So if I factor out an x squared, what do I have left? Plus 1. That was the first one we looked at. Let's look at the second one. What do they both have in common? Negative 4. They both have a negative, and 4 fits into both of them. If you factor out a negative 4 out of both of those, what do you have left? Now, here's the easy way of doing that. Whenever you factor something out, to see what goes inside here, divide both of these by what you factored out. Negative divided by negative becomes a positive. 8 divided by 4 is 2x. The negatives cancel, so it's a plus. 4 divided by 4 is 1. Now, only because what we have in these parentheses are the same, we can go further. If these were not the same, we're done. We can't do anything with that. We can't use this method. We can't use grouping. Repeat the process. We have one term here, and we have one term here. What do they both have in common? They both have a 2x plus 1. If I take out the 2x plus 1, what do I have left? Very good. Very good. Many people won't see that. But if you took out the 2x minus 1, you have the x squared. If you have to take 2x minus 1, you have minus 4. Very good. Can we do anything with this first one? How about the second one? Can we do anything with that? Can we go any? Can we factor any further?
X minus 4 and x plus 4.
No. Close though. I know what you're trying to do. Because what times what is 4? 2 times 2. So it's x plus 2, x minus 2. You were close. You were very close. That's what I said, you were close. I was very close. Now, the degree is 3. We're supposed to have 3 solutions, and here they are. Let's go ahead and sketch this. What's our y-intercept? What are my x-intercepts?
It's -1, x -1, x.
No, not done yet. -1 is not a solution.
Are we talking about x-intercepts right now?
Yeah. Let's do the easy ones first. Since you have more time, what are these intercepts? What's that one?
X equals +2.
Yeah, so it's +2,
Right.
and
X equals
-2. Those are the easy ones. Now, whenever x has a coefficient, it's going to be -1 divided by whatever that is. So if I had 3x plus 5 as my intercept, so that would be at -5 over 3. If you don't see that, set it equal to 0 and solve for x. What's the first thing you do? 5 over. It makes it -5. Then you divide by 3. Get the x by itself. So whenever you have a coefficient, that's always becomes the denominator. So it's going to be -1/2. Those are my x-intercepts and my y-intercept. What do we know about the end behavior? What is A?
A of n, yeah, A of n is 2.
Which is positive.
Which is
And
positive.
N is?
And N is 3, which is odd.
Which is odd.
So they're going to go in opposite directions.
Opposite directions. And the right-hand side, since it's positive, goes up. Left-hand side goes down. So the question is, notice in the one we just did earlier, how do we know if it just bounces or if it crosses? What you're going to do, they're all going to cross. Because the degree of each one of these, the multiplicities are all odd. If the multiplicity is odd, then the line crosses at that intercept. If the multiplicity is even, it'll bounce. So if the multiplicity is odd, the line crosses that x-axis. Crosses x-axis. If it's even, it bounces. Off the x-axis. So if the multiplicity is even, remember, the multiplicity is the exponent of our factors. So we know at x equals 2, it's a multiplicity of 2, so we know at 2 it bounces. Let's go ahead and look at, I'll make up one, and we'll see what this means, what it looks like. Polynomial, I'm going to give you the factored form. There. Sketch this graph. So you got it to the factored form. You have to figure out what those are, because you have to know what the basic shape of the graph is. Is A, basically, A sub n, just, is it positive or negative? That's all you have to know. Is A sub n positive or negative in this example?
Positive.
Why?
Based on the x that I was looking, the one that's not in parentheses.
Nope, you have to look at all of them. Because A sub n is the leading coefficient. It's the coefficient of all of these terms. And you have to look at the power. Because if A was negative here, to the 5th power, it stays negative. Negative to the 6th is a positive now. So, is A going to be positive or negative? Well, since all of these are 1s, positive. What's my degree? What's n? Nope.
Are we adding all of these
Ah, look at your notes. How does n relate to multiplicity? That's not what I said. I'm asking you to look at your notes. We just talked about that about 10 minutes ago. What does n tell you? N tells us what?
The degree,
What does the degree tell us?
the shape of the graph, the number of solutions.
The maximum number of solutions. So how many solutions are we going to have?
Solutions?
Nope. First off, what does x minus 2 to the fifth mean? It means x minus 2, x minus 2, x minus 2, x minus 2, x minus 2. That means there are 5 x-intercepts there. That's what this tells us. So there's 5 solutions here, there's 6 solutions here, so tell me how many I have total. What is my n? How'd you get 11? Yeah, you can't do that. Because each one of these play an important role in it. There's 1 plus 5 plus 6 plus 2 plus 1 plus 2 equals 17. So why is that important?
Because that tells us whether graph is going to either cross or bounce off all 17 x-axis.
Nope. Exactly. So all this tells us is the direction of the graph. Does it go same direction? Does it go opposite direction? Does it go up? Does it go down? That's all it tells us. So what is it going to tell us? What do we know about the end? This is called end behavior, by the way. So what do we know about the end behavior? It's odd. So what does that tell us? Okay, it goes opposite directions.
Goes opposite directions, and it's
Positive, so it goes
right. So the right hand side's going to go up.
right.
The left hand side's
Right hand goes up because it's positive. It's an increasing function. So the right hand side's getting positive. Left side's. So what are my intercepts? My intercepts. It's not that difficult. Just looking at it right there, you tell me, just off the top of your head, you can tell me by looking at them. You get -5. Let's go left to right. So I know what you're trying to do. What's my first x-intercept?
itself. The next intercept is 0.
0, yeah. Set each of these 0. So we have 0 is one of them. What's the next one?
Next one.
I don't want 2 and 0. I just want the x-intercept, the number.
X equals +2.
+2. Next one? Keep on going.
X equals positive 5. X equals negative 5. Plus 1 is x equals positive 4.
Very good. Just take each one of these, set them equal to 0, and that gives me the value, the x location, the 0 number. You're absolutely correct. Let me get back. When I asked you for the x-intercept is a location. So it is at negative 5, comma 0. We're looking for here are called zeros. X equals negative 5. X equals negative 1.
Right, because just based on the x equals negative 5 alone, that tells you already the point. Already at 0.
Right. Because that means if I take x inside this whole thing, if I put negative 5 in place of x, inside all these places, it becomes 0. If I put negative 1 inside of all of these, the answer will be 0. Because negative 1 plus 1 is 0. 0 times anything is 0. So these are called zeros. These are called x-intercepts, or locations. Very good. So what do we know about the end behavior of this function? Different directions? Up or down? Going to the right. Right. Because it's positive and it's yes. So from the last endpoint to the right, we know it's going to go up. From the last endpoint, it's going to go down. That's why they call it end behavior, because it's the last dots of our intercepts. Okay. All we have to do is think about what's going to happen to the rest of those points. Let's look at negative 5.
Right.
Does it cross or does it bounce?
It crosses.
Why?
It crosses because the multiplicity is on.
Very good, because it's 1, so we know it's going to cross. We don't know how high it's going to go, but we know it's going to go. What happens at negative 1?
That is also going to cross.
Based on what?
Based on the multiplicity of the factor.
Which is 6.
6.
Well, they're obviously different. One's odd, one's even, so no, one of those is wrong then.
Okay.
Why?
I think at x plus 1 over 6, the multiplicity is 6.
Since it's even,
it
bounces. If you ever forget, what does the graph x squared look like? It bounces off 0. X cubed looks like this. It crosses and it bounces. So that's where it all starts from. What happens at 0?
It crosses because the multiplicity is on.
So we know it's going to do this. At 2,
Also going to cross.
because it's 5, it's odd.
Right. Or it's going to bounce off.
At 4, it bounces.
Mm-hmm.
5.
At 5, it's also going to bounce since it's an even number.
Very good. So it looks something like this. And that's how you use multiplicities. Again, that's if you get it down to the factored form. That's what we're getting to. That's the hard part. Okay, that's enough examples for those. Let's go back to So what we're trying to get to here is we have to get the function, well, if I give you a polynomial, the first thing you have to do is factor it. You have to take this function and break it down to its smallest pieces. Since the degree is 2, we know there's going to be at most 2 x-intercepts. Remember how we do this? Whenever you're solving for this, you're always solving for the middle variable. So it's going to be x and x, because x times x gives me x squared. Second, look at the second sign. If the second sign is a plus, that means they're the same. They're both going to be whatever the first sign is. In this case, they're both going to be pluses. Now we got to figure out, so that takes care of, the first part takes care of the x's. The second part takes care of the signs. Now we got to get the numbers. Right. What we have to do here is take the first term, which is 1, and the last term, multiply them together. Now from there, we got to find what two numbers multiply to give you 6, since this is plus, that when you add them, you get the middle number. You're right, it's going to be 3 times 2, 3 plus 2. All right, so that's stuff we've been doing all along, factoring. We know then is this. Let's say we divide both sides by x plus 3.
On the right side of that, x plus 3 that cancels out.
We should get x plus 2 as a final answer if we do this division. That's what we're going to have to do first. So, well, let's look at this. There are two methods we're going to use here in this section. One of them is called long division. The other one is called synthetic division. They both serve their own purposes, but they end up with the same result. So first off, we're going to look at long division. What is long division? (24) divided by 6. With that, we can rewrite that as 6 goes into 24. How many times does 6 go into 24? 4 times 6 is 24. Subtract them, you get 0. So yeah, so 24 divided by 6 is equal to 4. Now, what does this mean? This means that 24 is equal to 6 times 4. Because if we had 24 divided by 6 equals 4, I can multiply by 6 to both sides, then I get this. 6 and 4 are factors of 24. We know they're perfect factors because the remainder is 0. If the remainder is 0, then we have perfect factors. Let's look at this. We do the same thing. We have whatever the bottom, the divisor. Bless you. X squared plus 5x plus 6. We set it up the same way. Now we have to only look at the leading terms. What times x gives me x squared? What times x gives me x squared? So what do I put? You're exhausted. I can tell. So x. X times x gives me x squared. So whatever we have there, let's check it. X times x is x squared. X times positive 3 is positive 3x. Which is what we did here. We took 4 times 6 is 24, and then we subtracted them. That's what we do here. We now subtract both of these numbers. X squared minus x squared, that cancels, that's good. 5 minus 3 is 2x. Bring down everything else. Repeat the process. What times x gives me 2x? Kind of 2. Positive or negative. You have to be very distinct about the signs. Positive 2 times x is positive 2x. Positive 2 times positive 3 is positive 6. Change the signs and subtract. The remainder is 0. So the answer is x plus 2, like it's supposed to be. Since we have x plus 3, it goes into this many number of times. What this tells us is this times this equals that. Therefore, we know that x plus 3 times x plus 2 is equal to x squared plus 5x plus 6. That's what we're trying to get to. This helps us find the factors. Let's look at one of the examples we just did in the past. Polynomial. hate this camera. I hate it with a passion. Let's find the other answers. So the way we do this, we take x minus 2, 2x cubed plus x squared minus 8x minus 4. Repeat the process. Start off by looking at the leading terms. What times x gives me 2x cubed?
X squared.
2x squared. Very good. 2x squared. Now we take this in and multiply both of those. 2x squared times x is 2x cubed. Positive times negative is negative. 2x squared times 2 is 4x squared. You're going to change the signs because now you're subtracting them. So change the signs and add. First term has to cancel. If it doesn't cancel, you did something wrong. So we have 4x squared plus 1x squared is 5x squared. Repeat the process. What times x gives me 5x squared?
5x.
Just 5x? Positive 5x, yes. So let's check it. 5x times x is 5x squared. Positive times negative is negative. 5 times 2 is 10x. Signs and add. Term cancels, which is what we need to have. 10 minus 8 is 2x minus 4. What times x gives me 2x?
Negative 8.
What?
Oh, wait, are we talking what times? I'm sorry, can you repeat that question?
Well, we just did this. We just added them together. So look at the leading terms. What
Okay.
times x gives me 2x?
2.
I thought you were just tired.
I'll take my coffee this morning.
Negative 8. So let's check it. Positive 2 times x is positive 2x. Positive times negative is negative. 2 times 2 is 4. Change the signs and add. So the remainder is 0. Now, the remainder is 0, which means that x minus 2 is a factor. So x minus 2 is a factor of our polynomial, 2x cubed plus 8x minus 4. We're supposed to have 3 answers. Can we go any further? Yes. We're supposed to have 3 answers. We just found one of them. We don't need the big one anymore. We now only look at this. Let's factor out this one. Once you reach a result of 0, a remainder of 0, all you have to do is take the top part now, because we're done with this one. So how do we fix that one? Can we factor it? Well, let's try it. Since this is the leading coefficient is not 1, then we have to put 2x and 2x. Look at the second sign. It's a plus. It means they're both the same. They're both the first sign. Let's figure out, take the first term and the last term. 2 times 2 equals 4. So we figure out what times what equals 4. That when we add them, we get 5. 1 plus 4, right. So we could put 1 and 4 inside there. Because our leading coefficient wasn't 1 when we began, can we factor anything out of these? Can we factor anything out of the first one? Can we factor anything out of the second one? Do they have anything in common? We have a 2 in common, so we have x plus 2. So once we do that, whatever we factored out, erase it. So this polynomial factors out to that. So polynomial that we started off with can be factored out into, since we had an x minus 2 with 0 remainder, we know it's x minus 2. And this one, the remainder of it, was x plus 2, 2x plus 1. These are the factors of that. Now, can you put all this stuff I just talked about together? What did we just do? We used division to determine, to see the factors of a polynomial. As long as the remainder is 0, then the denominator is a factor of the numerator. So what we just did here, by doing this whole process, we factored out the polynomial into these, so now we know our x-intercepts are those. The process here is to find the x-intercepts of our process, of our polynomial. Do another one here. X plus 1, x minus 3 factors of x cubed plus 2x squared minus 5x minus 6. Are they factors? Can't tell by looking at them. This is math class. So how do you figure out if they are factors?
Is that where long division comes in?
If are factors, long division have a zero remainder. So let's look at x plus 1 first one. Just to both of them, actually. Same thing with x minus 3. What times x gives me x cubed? Take this and multiply both of those. X squared times x is x cubed. Positive, positive is positive. X squared times 1 is x squared. Change the signs and add. X cubed minus x cubed cancel. 2x cubed minus x cubed is 1x x squared, I mean. It's down. The process. What times x gives me x squared? Positive x. So positive x times x is x squared. So now we'll take this. Positive and positive is a positive. X times 1 is x. Change the signs and add. Negative 5x minus 1x is negative 6x minus 6. What times x gives me negative 6x? So negative 6 times x is negative 6x. Negative times positive is a negative. 6 times 1 is 6. Change the signs and add. Remainder is 0. X plus 1 is a factor. And do the same thing with the other one, using long division. Times x gives me x cubed. Squared times x is x cubed. Positive times negative is a negative. X squared times 3 is 3. Change the signs and add. X squared minus 5x minus 6. Repeat the process. What times x gives me 5x squared?
5x.
A positive 5x. Because if you just put 5x there, it's just x squared 5x. You have to have, it has to be an equation. So Signs are very important. 5x times x is 5x squared. Positive times negative is a negative. 5 times 3 is 15x. Signs and add. It's 10x. What times x gives me 10x? Positive 10. Positive 10 times x is positive 10x. Positive times negative is negative. 10 times 3 is 30. Change the signs. 30 minus 6 is 24. So that does not equal 0.
So x is not a fraction.
Is So this is pretty much what's telling us. This is the remainder theorem. If the remainder is 0, then our answer is a factor of it. So x squared plus x minus 6 times x minus 1 equals this. So we're factoring, we're breaking down to smaller pieces. Because what this tells us that any fraction we have, let's say we had 3 goes into 24. Any fraction we have in there breaks down into its smallest pieces, which in math terms, we're looking at of x is equal to times q of x plus r of x. These are all functions. This is called a dividend. D is called the divisor. Q is called the quotient. And R is called the remainder. Now, where does all this stuff fit what we just did? End is our big equation. It's divided by a divisor. And that's going to equal some quotient. If there's anything left, it's a remainder. So it's easy. If the remainder is 0, we have here is this. Let's look at this first one. We have here is x cubed plus 2x squared minus 5x minus 6. That's the dividend, the big number we're dividing into. The divisor was x plus 1 times our quotient, which is x squared plus x minus 6. So our remainder was 0. That was the first example, because we had a remainder of 0. But the second one, x cubed plus 2x squared minus 5x minus 6 is equal to x minus 3. It gave us x squared plus 5x plus 10. The remainder is 24. So the remainder is 24 divided by the x minus 3. That's how you'd write the answer there. If the remainder is 0, then the divisor and the quotient are factors of the dividend. If the remainder is 0, then the divisor, which is the bottom number, and the answer are factors of that number. So far, so good? Let me show you a shortcut now. The shortcut, see, that's why I'm going to need you to stay focused because I notice your mind is elsewhere right now. I know your head is elsewhere right now. Oh, we'll be out here. Yeah. No, just tell me. Yeah, if you need to, just tell me. And yeah, we'll be out here by 10. Well, actually, we should be out shortly. So I'm going to show you now the shortcut. To long division, synthetic division. But synthetic division has its limitations. Synthetic division divisors of the form x plus or minus some number. You cannot have a coefficient. Or exponent, you cannot have a power. So synthetic division only works when you have functions that divided by x plus or minus a number. The steps. We're going to do an easy one first. We know this equation is true. X squared plus 5x plus 6 divided by x plus 2 has to equal x plus 3. In synthetic division, we don't use letters, only numbers. So first off, set up the synthetic division. Set? Yeah. Tired tomorrow or next time. So, yeah, and we're almost done. So yeah, you won't be missing too much today. But yeah, I'll post it. When you see the dividing symbol upside down, then it's synthetic division. So good luck in your meeting. So, oops. So first off, solve for the denominator. X plus 2 equals 0. X equals negative 2. That goes there. The reason that goes there is because that takes care of our subtracting and changing signs. That takes care of everything. All we do now is we're going to do a process of multiplication and addition, and we're done. Place the coefficients dividend to bracket thingy. You have to make sure that each column is allocated. So we have x squared, x, and 0. So we know we're going to have three possibilities, or three terms. The first one's going to be x squared, x, and the constant. I only want the coefficients. So what's the coefficient of x squared?
1.
Coefficient of x?
5.
And the constant?
6.
Bring down the first number. First number. Now, I still haven't figured out a simple way of writing this. All this is now is multiplication addition. We're looking at this term here. Multiply this term by this term, put it in that column. So negative 2 times 1 is negative 2. It's straight down. 5 minus 2 is 3. Repeat the process. Negative 2 times 3 is negative 6. 6 minus 6 is 0. There's your remainder. Numbers here, we start building up. This is our constant. This is our x term. So we have x plus 3. There's the answer. Let's look at some more examples. x to the third plus 7x squared minus 5 divided by x plus 3. This equation looks like this. And because our denominator is x plus or minus a number, we can use synthetic division. Plus or minus. So what number goes out here?
-3.
Very good. Take x plus 3, set it equal to 0. Now inside here, we have the biggest number is x cubed, so it goes down to x squared, x, then a constant. What's the coefficient of x cubed?
Coefficient of x cubed is 2.
Of x squared?
X squared is 7.
X
Is 1.
0.
0.
Because there is no x. It's 0. There is no x. Constant is -5. And the first term, multiply. -3 times 2 is -6. Add straight down. 7 minus 6 is 1. -3 times 1 equals -3. Plus -3 is -3. Times -3 is +9. 9 minus 5 is 4. There's your remainder. This is your polynomial. The constant, this is the x values, and this is the x squares. So this is going to give us 2x squareds plus 1x minus 3. 4 over x plus 3. Because that's the remainder. So that's how that works. Now, another reason this is so good what if I gave you f of 3? Into this equation. So let's plug in 3. We get 3 squared, 5. 3 squared is 9. 5 times 3 is 15. 6. 9 plus 6 is 15. 15 plus 15 is 30. So f of 3 is 30. Let's see something. This is pretty cool. Let's do synthetic division with this number and this equation. So this is x and constant. So it's 1, 5, and 6. And the first term is 1. 3 times 1 is 3. 5 plus 3 is 8. 8 times 3 is 24. 24 plus 6 is 30. Okay, that one didn't sound too impressive, but what if I gave you a much bigger equation? In other words, it's the same, they give you the same answer. F of 3 is 30, I use synthetic division. The remainder will be the answer. I don't need that much. The beautiful thing about synthetic division, you don't need much space. Find this. 2 to the 5th, 3x to the 4th, x cubed, minus 2x squared, x minus 8. Traditionally, you'd have to plug in 10 to the 5th, and that's a lot of work. Let's try using synthetic division. X to the 5th, x to the 4th, x cubed, x squared, x, and a 2, negative 3, 1, negative 2, 1, negative 8. Down to 2. 10 times 2 is 20. 20 minus 3 is 17. 17 times 10 is 170. 70 plus 1 is 171. 10 times 171 is 1710. Minus 2 is 1708. 10 times 1708 is 17080. And 1, so it's 17081. 10 is 1070810 minus 8, 802. It's 170,802. Much faster than the other way. Any questions so far? Notice, if you're doing this problem, I don't have to change the sign. But if I'm asking you for is this equation, then I have to solve for x. This is already x given to you. You're getting close to being done. Very close, actually. 5, 0, g of x. Oh, that's Is 5 a 0 that polynomial? How do you think we'd solve this? Good guess, yeah. So we put 5. This is x to the 4th, x cubed. I like to do that. You don't have to, but I like to know what I need. Because here, you see my equation, the coefficient of x to the 4th is 1. There is no x to the 3rd, so it's a 0. X squared is negative 26. There is no x. And 25 is the constant. Down the first term and go with it. 5 times 1 is 5. 0 plus 5 is 5. 26 plus 25 is negative 1. 5 times negative 1 is negative 5. 0 plus negative 5 is negative 5. 5 times negative 5 is negative 25.
Then it becomes 0.
0.
So it's 5 is a 0.
Exactly. So 5 is a 0. Last one. Is I a 0 of f of x? Because now we look at imaginary numbers. So let's set it up the same way. So we have I, x cubed, x squared, x, and constant. So we have 1, 1, negative 3. Now the first term, 1 times I is I. Negative 3 plus I is negative 3 plus I. One times negative 3 plus I. So 1 times negative 3 is negative 3 plus I times I is I squared. Remember, I squared becomes what? I minus 1. So we had 1 plus this. The 1's cancel. So we have negative. I times negative 3I is negative 3I. Changes the sign, so it becomes a 3. So the remainder is 0. I is a 0 f of x. Okay, that's that. It's repeating the same stuff, but now we put a bunch of numbers in there. But that's good. The better you understand how to do synthetic division, it's going to save you so much time in the next section. Because the next section, I'm going to give you a huge polynomial, 7, 8, 9 terms long. Ask you to factor it out. We'll use synthetic division over and over and over until we find all the factors. That's it for today.